Hello everyone and welcome to our video about communication theory. In this video, we are going to talk briefly about communication and about fax. What is a fax? How does it work in general? What are the different types of fax? How does a digital e-fax work and the evolution of it?
Communication is an important tool in our life. It facilitates the connection between others, helps us to decrease the distance, and to save time. It aids us in educational field. So, you can communicate via electronic devices and social media applications. Now, we are going to talk about the evolution of digital fax. First of all, what is fax? Fax is short for facsimile. In 1843, fax was invented by Alexander Bain. How does it work? Fax transmit documents by wire or radio wave. Common fax machines are designed to scan printed textual and graphical material and then transmit the information through the telephone network to similar machines, where facsimiles are reproduced close to the form of the original documents. When it comes to transmitting messages over phone and fax machines, there are two different technologies that can support the message flow. There is analog and digital, and both work in their own unique way. Analog takes the message and translates it into a series of electronic pulses. These pulses travel through the network and reach the device on the other end, which translates them back to the original message. On the other hand, digital technology breaks the original message into binary code. Essentially, this is a collection of zeros and ones that carry the message. This code is sent through the network to its destination. To be able to transmit digitally, there needs to be a receiving device that is able of reading and resembling this code. A benefit of digital fax transmission is the speed, in which it can be sent and received. Advantages of using fax machines. Fax machines do not have viruses or the many potential programming malfunctions that computers have. Faxing has reliability advantages over postal messages as well because mailing risks damage or loss, and all you need to successfully send a fax is a fax machine and a recipient number. Fax enables transmission of messages, data, diagrams, sketches, and drawing with high speed. It helps to send written information to any place within or outside the country accurately. Disadvantages. Fax has less privacy as the transmitted data can be handled by anyone who's beside the fax machine. Owning your own fax machine can be costly. It needs papers and telephone charges. Dependency on telephonic system. Fax uses telephonic system to transmit data, and if such system is down, then sending of data and information face problems. How does digital fax work? Internet fax, e-fax, or online fax is the use of internet and internet protocols to send a fax, rather than using a standard telephone connection and a fax machine. A distinguishing feature of internet fax compared to other internet communications, such as email, is the ability to exchange fax messages with traditional telephone-based fax machines. Internet fax services usually assign a fax number to each person who signs up for the service. People can send faxes to this number, and customers can send faxes via email without using a fax machine. Here's how it works. To send a fax through an internet fax service, the sender attaches a document to an email message. The document can be a scan of a paper document, or it can be created in a program like Microsoft Word. The sender addresses the message to the recipient's fax number, followed by the name of the faxing service. For example, 18005@emailfaxes.com. The service translates the attachment so that a fax machine can read it. Then, the service sends the data across the phone line. The recipient's fax machine decodes the data and prints the fax.
Now for standard fax transmission. How does it work? As a standard letter size sheet is fed through a machine, it is scanned repeatedly across its width by a charge-coupled device, also known as CCD. So what is a CCD? A CCD is a solid-state scanner that has 1728 photosensors in a single row. Each photosensor in turn generates low or high variation in voltage, depending on whether the scanned spot is black or white, since there normally are 4 scan lines per millimeter or 100 scan lines per inch. The scanning of a single sheet can generate almost 2 million variations in voltage. The high-low variations are converted into a stream of binary digits or bits, and the bit stream is subjected to a source encoder, which reduces or compresses the number of bits required to represent logruns of white or black spots. If we mentioned source encoding, it is briefly a process of turning an analog signal into a digital signal. This process has 3 steps, which are sampling, quantizing, and encoding, but is not our main topic for this video. So heading back to the fax transmission, the encoded bit stream can then be modulated into an analog carrier wave by a voice band modem and transmitted through the telephone network. With source encoding, the number of bits required to represent a typewritten sheet can be reduced from 2 million to less than 400,000. As a result, a standard fax modem speeds up to 56,000 bits per second, though usually less, but a single page can be transmitted in as little as 15 seconds. Communication between a transmitting and the receiving fax machine opens with the dialing of the telephone number of the receiving machine. This begins a process known as handshake, in which two machines exchange signals that establish compatible features such as modem speed, source code, and printing resolution. The page information is then transmitted, followed by a signal that indicates no more pages to be sent. The called machine signals receipt of the message, and the calling machine signals to disconnect the line. At the receiving machine, the signal is demodulated, decoded, and stored for timed release to the printer. In older fax machines, the document was reproduced on special thermally sensitive paper, using a print head that had a row of fine wires corresponding to the photosensors in the scanning strip. In modern machines, it is reproduced on plain paper by a zero-graphic process, in which a minutely focused beam of light from a semiconductor laser or a light-emitting diode, modulated by the incoming data stream, is swept across a rotating electrostatically charged drum. The drum picks up toner powder in charged spots corresponding to black spots on the original document and transfers the toner to the paper. Here's a fax transmission example to simplify the operation. A fax transmission works in steps. The fax machine's handshake transmit their message and then send confirmation. Step 1. The handshake. The sending machine waits for the line to pick up and then starts sending a series of beeps. These beeps signify that the machine is requesting to send a fax. The sending fax machine is essentially saying, "Hey, I'm a fax machine. I'm looking for another fax machine. Is there one?" If the machine on the other hand is also a fax, that fax will answer the beep with its signal. At this point, the receiving fax machine is saying, "Hey, you're a fax. Guess what? I'm a fax too." And both machines now know that they have made each other a friend. Once both machines have acknowledged each other, they send information back and forth about them, just like two people getting to know each other. This information is along the lines of whether they are analog or digital faxes, as well as what compression formats they speak. Once the two fax machines understand what the other is capable of, they decide on a format to send with and then start their transmission. Step 2. Transmission of messages. After the handshake has occurred, the sending fax will send the message through the receiving fax. As both machines know that they speak the same language, they are able to send the messages through in a format that they know the other machine knows. The final step is the confirmation of the message being received. The receiving fax machine will send a confirmation notice, which is that the sending fax machine can now print out. Finally, coming to the evolution of digital fax machines. Although the Group 2 fax machines proved to be successful in business applications, where electronic transmission documents containing non-textual information such as drawings, diagrams, and signatures was required, the slow transmission rate and the cost of the terminals ultimately limited the growth of fax services. In response, the CCITT developed standards for a new class of fax machines, now known as Group 3, which would use digital transmission of images through modems, with the encoding of a scanned image into binary digits or bits. Various image compression methods, aka source encoding or redundancy reduction, could be employed to reduce the number of bits required to represent the original image. By coupling a good source code with a high-speed modem, a Group 3 fax machine could reduce the time required to transmit a single page to less than 1 minute, a threefold improvement in transmission time over the older Group 2 fax machines. The Group 3 standard was adopted by the CCITT in 1980. Originally, Group 3 fax was intended for transmission at data rates between 2400 and 9600 bits per second. With advances in voice band modem technology, data transmission rates of 28,800 bits per second and above became common. Between 1981 and 1984, the CCITT sponsored the development of high-speed fax service that was adopted as the Group 4 standard in 1984. Group 4 fax was intended to supplant Group 3 fax by permitting error-free transmission of documents over digital networks, such as the Integrated Services Digital Network (ISDN), at speeds up to 64,000 bits per second. At such rates, transmission time for a single page could be reduced to less than 10 seconds. Group 4 fax has been deployed in areas of the world where ISDN lines are readily available, like Japan and France. However, since other areas like the United States do not have many ISDN lines installed in the local telephone loop, Group 4 fax machines must also support Group 3 fax for transmission over analog lines. So that's the end of our video. Hope it helped you out. Thanks for watching and peace.